It's time for Myth of the Week.
All right, so the reason I pulled this one out, because, and it's really funny because, like, when you look at my picture, basically it looks like there's like a number 10 bonding jumper going up to that sheet metal screw. That sheet metal screw would probably be a code violation in the NEC, and a lot of people correctly answered that. And the thing is, this is probably a European install, so there's probably they might be able to get away with that stuff. And it was funny too, James. I didn't understand what was going on with that other sheet metal screw that was coming in the side over there on the left hand side.
Yeah, I see it.
But regardless, you can tell that basically all these conductors are made to one common point in this Wago wire connector. I'm not saying that's a Wago brand, but it's some type of Wago design. But like I say, it looks funny to me that it looks like they actually tried to increase the size of that bonding jumper, because it looks like all the conductors in there are smaller and that bonding jumper looks to be a little bit larger. But regardless, we ran into this before, and like a lot of the stuff that's in 250 122B is kind of controversial. A lot of guys say, oh, well, it could just be sized from a qualified person. But the whole thing is, it's like, really, in all actuality, how is that really recognized by the AHJ? And that's always been kind of a little bit of a controversy there. A lot of people don't realize this. Basically, where it comes up and it like kind of rears its ugly head is when you get into like HVAC, and guys say, well, just to be safe, I'm going to pull a number 8. Well, now all of a sudden the unit comes out and it's 15 amps. Well, you're 4 times larger ungrounded conductor than you need that's adequate for that appliance. So now you have to upsize the equipment ground proportionately. And so that's kind of where a lot of these people get mad about this. I know we've ran into this before with a lot of times it's like number 10. So if you have like a number 10 NM cable, you're going to have a number 10 equipment ground in most part. I know there's probably is some NM manufacturers out there that probably do run a D-rated ground, like that's in for like a previous code cycle. But when you look at the current code cycle, what does the NM cable come out? It comes out with number 10 conductors with the number 10 ground, because that's what you need for 30 amps. So that's kind of where I see it, James. And when a cable manufacturer is producing their cable with a number 10 full-size ground in there, then that tells you that that's going to have to be, coincide with your bonding jumper as well.
Right. Just comment on the illustration. Looking at it, it looks on the far left-hand side of that illustration, there's a number 10 that's coming into it, and I think they're basing that equipment bonding jumper off the largest conductor coming in, and then the rest of them look like it can be 12s. That's what it looks like to me.
I agree with that. That's a good call.
Okay.
It's just hard to see any of the number 10s in there.
All right. Now, when you look at this, it's the answer to the question is going to be true. Now, there's more to it than just looking at 250.122B. When you get into this, you have to look at other sections. And the thing that gets me, and sometimes you may need to look at a code making panel substantiation to clarify a few things. But this is where we've gotten into a problem here lately, that there's some that are out there, they'll read something and just say that's it without looking at the rest of the code. And that's something I've said over and over and over. You have to look at all the code. You just can't pick one section all the time and say that applies, through the whole code. That's not going to work. So what I did here is I wanted to take a look at a few things right off the bat. Now, when you look at 250.109, it talks about the metal enclosures. Now, something we've discussed is we did last week was about is the metal conduit and the metal boxes, everything, will that provide a better equipment grounding conductor path back? And the answer is yes. I've actually been to a seminar that was done at NFPA that Georgia Tech University came in, that was presented by Rich Boyd, and
Nice.
they showed the documentation. I saw it. I know for a fact that's true. So when you look at this, it talks about metal enclosures, and it says shall be permitted to be used to connect bonding jumpers or equipment grounding conductors to both together become part of what? An effective ground fault current path. Now, if you remember last
Yeah.
week, we went over this, and one of the first things I talked about, I started where? In Article 100, and I started on the effective ground fault current path. And then I
Yes, sir.
tied everything in from 250.4A5 and B4 and just, I went through the whole thing. That's sort of the same thing here. You've got to have an effective ground fault current path back. Now, the metal, the equipment grounding conductor going over there, and the equipment bonding jumper, that's all a continuation of the effective ground fault current path. So that
Yep.
means whatever you're going over there with, everything has to be sized accordingly. You cannot size down. Okay?
Yeah, and you think about it, and we were talking about this. Like if you go out to like a junction box somewhere, and you're pulling number 6, even though it's on a 20 amp circuit, you can't just all of a sudden drop to number 12 because it's on a 20 amp overcurrent device.
Sure, you can. You upsize those conductors, and more than likely it was due to well, there's only three reasons it's going to be updated, or I mean upsized. You're either going to have voltage
Right.
drop, you're going to have a correction factor, or adjustment factors. That's what's going to
Right.
cause it. Okay.
Temporal.
Now, when you go over after that, then you look at the continuity of the equipment grounding conductors and attachment in boxes. Okay. Now, what
Yeah.
it says here, a connection used for no other purpose shall be made between the metal box and the equipment grounding conductors. The equipment bonding jumper and equipment grounding conductor shall be sized from what? Table 250-122 based on the largest overcurrent device protecting circuit conductors in the box. Now, this is where it's interesting because they literally say here, well, if you read that section, you have to apply table 250-122 just for the bonding jumper. And it does,
Right.
and 250.122B doesn't apply. And I said, okay, well,
Yeah.
let's take a look, because this particular change took place in the 2023 National Electrical Code. Matter of fact, this change is in our publication. All right. Now, when you come over here and look at this, this is the first revision part that they did to 250.148. And this is all I did was put the committee statement. And it says changes made to this section clarify that all equipment grounding conductors in a box are to be connected to each other. This ensures that the equipment grounding conductor of any faulted circuit is routed with the ungrounded conductors of the faulted circuit. And watch this. Language is added. Now, they added this so there wouldn't be this confusion, but of course, you got people like Ted Fritz and them over at ECD that don't go and look at the committee statement to see what their intention is. But there's a reason they added this, and it's added to ensure the common bonding jumper to the box is sized to what? 250-122. It doesn't say table 250-122 because it's automatically assumed you're basing on the overcurrent protection device. But if you have to upsize it, it's all contained within 250-122. So therefore,
Right.
250.122B would apply in this case because
Right.
it's a continuation of the equipment grounding conductor. All right.
Yes, sir.
So then
Yeah.
when you come over here, here's your table, and just say you had a 20 amp and you pulled a number 12, but you upsized and went to a number 10 because due to
Yeah.
voltage drop. Now you're going to have to make that equipment bonding jumper match that. And then when you come over and look at 250.122B, this will be based on the size of the circular mill. And I've done an example of this before, but if you look at this, the exception says equipment grounding conductors shall be permitted to be sized by qualified persons, and the exception to provide what? Looky there, an effective ground fault current path where we started in 250.109. And then I said, when you go look at that in Article 100, that ties you in with what? 250.4A5 and B4. And that's where it all has to be continuous and permanent and sized together. That means it's an extension of it, that equipment bonding jumper, because it is part of the equipment grounding path that provides that effective ground fault current path. Okay. Now, as an example, I've done this type of example before, but when they're looking at this and it says shall be, if you look at 251.22B, the last part of this, it says if installed shall be increased in size proportionally to the increase in circular mill area of the ungrounded conductors. Okay. Now, let's say you got a 200 amp panel. Let's just say I'm taking a feeder over somewhere. Say I'm feeding another panel and it's 175 amps. Even though I've got a 200 amp panel board over there, we'll just say we're taking over there with 2 conductors, which are good for 175 amps for 75 degrees C. So I go over there, I feed that panel. But now all of a sudden, due to voltage drop, I have to increase the size of that. Now, if I do that, say I did my calculations, I did the voltage drop last week and the week before going over those calculations. But if I increase the size of that, now let's say we increase it and we decide we need a 3-aught conductor. So what'll happen here is you'll go over to chapter 9, table 8, and you're going to pick up the circular mill for the 3-aught conductor and the 2-aught conductor. You're going to divide that circular mill in from the 2-aught to the 3-aught conductor, and that'll give you a multiplier. It's like 1.25683 or something like that. Then if I come back here and I look at this and I pick up 175 amp, it says I needed a number 6 going over there, right? For copper. All right. Now, what you'll do there is now you're going to go over, and I can tell you it's going to increase one size, but you go over and you go to chapter 9, table 8, pick up the number 6 circular mill, and then what you got on that multiplier there, you'll multiply that circular mill by that multiplier, and then you'll get your new circular mill and you'll size it, which would have came up to a number 4, because I think it's like 43,000, something like that. But it'll come down and it'll set it up that way, and that's how you do it based on the circular mill. Now, if I'm making it, if I go over to that panel board and say I had to make any bonding connections in there, what are you going to base that off of? You see what I'm saying? It is all part of a continuation. And that's why I say you do one to a box. You're doing it just like if I went over to a panel board, I might be bottom feeding it or whatever. You got to make sure the conductors are large enough. And to give an example, say if I go look at 250.32 B1 and B2. Now, when it first come in the code, it was 250.32 B exception. And basically what you could do, I could go over to another building or structure and I could use equipment ground over there coming back and a neutral. Now, if I didn't have an equipment ground, I could use the neutral as the equipment ground. But what happened in that case? It said that you need to take and determine what the size equipment ground is and what size the neutral is, and whichever is the largest between the two is the one you'll use for that path back. It's the same concept. If I go over there to another panel board and I'm feeding something and I got to bond everything in, you got to make sure everything is matching up, and then you go look at 250.102C. You see what I'm saying? There's a lot of it, and what they're saying does not consistently match with the other things that you do in the National Electrical Code. Now, I could sit here and go over all day just showing all these calculations, everything, to prove my point. But what I'm trying to say here is you can't pick and choose where you want to apply something. And I think this here is a good example showing that you create that effective ground fault current path